Hello folks, this is 2021 May June paper 1-2 and the question number is 13. It belongs to the chapter forces and it's about moment or torque. It says that a unique square sine of weight to 40 Newton, so weight 40 Newton, it is a W here, is suspended vertically from its top edge by a horizontal hinge. So this is the hinge, this is suspension state. And when you look from the sides like this, the view is like this. So this is the front or back view, this is the side view is like this. The hinge is not frictionless, so that means there is frictional force here. When the sign is displaced from the vertical, somewhat like this, we make it like this or like this, vertical by an external force and then released. So we do it and then release it. It does not return to the vertical position. So we release it, but it doesn't return here. It remains somewhere there. The maximum, it's because of friction, because friction is trying to prevent that. So the maximum torque exerted by the hinge on the sign is 6.0 Newton meters. So this, because of this friction, what happens is the maximum torque exerted by the hinge on the sign. So that frictional force is giving a torque of this much. The sign is displaced by 90 degree, it like this, so that it is horizontal and then released. So it gets stuck somewhere here. So let me draw that diagram here. Let me say it gets stuck in this position. So now we have to find at what angle to the vertical does the sign hang. So we have to find this angle. Now what happens is when it is at this state, its weight acts along this direction. So this is the direction of the weight, which is equal to W is equal to 40 Newton. Since this is 0.8 meters, we have got this whole thing is 0.8 meter, and this thing is from here to here, it is 0.4 meter. Now since this is theta, this angle will also be theta. Now what happens is, let us find this thing will apply a clockwise torque on this thing. So the clockwise torque is tau clockwise is equal to weight into this distance, which is 0.4 into sine of the angle between this radius and the line of action of force, which is equal to theta, smaller angle, so it is sine of theta. This is the clockwise torque. The next is the anti-clockwise torque is given by the hinge. So the hinge tries to do it like this. So it is anti-clockwise torque, and that anti-clockwise torque is equal to tau A is equal to max is 6.0 Newton meters. So when it is hanging there, the two torques should be equal, clockwise, anti-clockwise, which means that W into 0.4 into sine of theta is equal to 6. So this gives us sine of theta is equal to 6 by W into 0.4, which is 6 is there, W is equal to 40 into 0.4, which will be equal to so let me do the calculations. So it is when I do this, so this is 6 by 16 by 16. So let me do just this thing. So theta is equal to sine of inverse, it is 6 by this is 16. So when I do this, it is 22.02 some degree like this, which becomes ultimately, when I write in 2SF, I can write it as 22 degrees. And this is in choice number B, so that's why choice number B should be the correct choice.